webinar. On the sixth webinar on Open RAN in Indonesia, with the title "Secure Your Path to 5G with Open RAN." Yeah, thank you so much for your coming. Yeah, I would like to introduce myself. My name is Yuda Febrianta. So I would like to thanks and welcome to all of you who have already attended this webinar. And this webinar is actually brought to you by Telkom University, the primary private university in Indonesia, and also considered as the best private university in Indonesia. Also organized with TechBros, yeah, a startup company based in Germany, Romania, and Indonesia, and also Telkom Infra Project, TIP, as the home of the vendor, operator, and any other entity focusing on the telecommunication, which is supported the development and the deployment, the state of the art of the telecommunication industry. So we are collaborate together here in Indonesia to expose and popularize the new technology in telecommunication. So by using or by introducing the technology, yeah, the test case, use case in our lab. Yeah, it is basically I am also as the coordinator of the IP community lab at Telkom University. It is the lab which is located on Southeast Asia. It is 14 in the world basically, and located in the neutral host or university here in Indonesia. So yeah, during the pandemic outbreak, yeah, I hope all of you still in the good health and the good condition. Yeah, we need to always take care about ourselves. Yeah, we still trying to provide the community for the awareness and sharing knowledge at the community on the 5G telco network, or maybe the other technology which is introduced later on. Okay, thank you so much for being here. So basically today we will have the experience and good practical expert, yeah, from the industry. So we would like to introduce you. The first speaker is Mr. Timo Jokiaho. Mr. Jokiaho, thank you so much for joining us. How are you, sir?
Thank you.
Yeah, okay. He is the Chief Technologist Global Telco Ecosystem. He will present the presentation, which is entitled "Going Towards the Edge or RAN or 5G with Cloud Platform using Virtual Machine and Containers." Yeah. And then the second speaker, it is Mr. Kundan Das. Hello, Mr. Das. How are you today? Okay. Yeah, I think he will join us later, yeah, maybe, or maybe he is already available here. He is Senior Director on Star for Asia Pacific ANC, yeah, 5G and Open RAN. He will present about 5G and Open RAN from the Star. So I think without further ado, please, we would like to invite Mr. Jokiaho to present your material. So please.
Okay. You can see my slides, I hope.
Yes. Yep.
Let me put it in the presentation mode.
Presentation mode. Okay. Thank you so much, sir.
Still see it?
Sure. Yes, already.
Good. Okay, all right.
The time is yours.
Thanks a lot. Yeah, thanks a lot for the introduction. Yes, so my name is Timo Jokiaho. I'm a Chief Technologist at the Red Hat Telco ecosystem team, and I'm based in Finland. I've been at Red Hat now 7+ years. And before that, I was being a Finnish engineer. I have, of course, been a long time at Nokia doing RAN, proprietary RAN. I have also been at Huawei, Germany, China, and Samsung before coming to Red Hat. So fairly strong equipment provider background. Now, before I start really going through my material, I think it's worth saying, which people probably know very much, is that Red Hat is not a RAN vendor. We don't do RAN. We are a open source platform vendor and open source tools vendor and everything which is around open source products. But we are playing a major role in Open RAN or vRAN, whatever you might want to call it. So with that introduction, I start with my standard slide, which we always need to a little bit talk about, which is our unique development model. There's a reason why we need to talk about it, because it is unique and it has been very difficult to understand in telco communities, service providers and our partners as well. So what we do is that about 75–80% of our engineering, software engineers, software developers, they work directly in open source communities, which is in the middle of this slide. So we don't develop our products or our code, which is not actually our code, it's an open source code. We don't develop that in Red Hat, closed source project. We develop them directly in the open source projects. And from there, we downstream the community releases, whether it's Linux distribution or OpenStack or container platform, whatever, we do the same. So we downstream, we fix the bugs and push everything back. And eventually we create Red Hat supported products, which are on both hand sides of this slide. And why we call it upstream first is an important thing to understand. So we can commit to new features in our products only after it has been approved by upstream community leadership. And if upstream community leadership does not approve a feature, it will not appear in our products. So it has to be first in open source communities, and then we can commit to that feature or new features with the long-term maintenance. It's important to understand, and as I said, many people have still difficulties to understand this model, but that is what Red Hat has been doing for 25 years or more. Now, going forward, just one slide on our platform strategy. So again, we do not have applications for any purpose, not for RAN, not for core network, not for IT, not for anything. We are a pure platform and tools vendor, and our strategy is to build a platform which we call horizontal telco cloud to all use cases in telco industry. And in a broader perspective, the whole Red Hat strategy is common cloud infrastructure for all use cases, including IT, including networking, including enterprises and everything. And of course, today we talk about the radio access and Open RAN model. Now, very quickly, as everybody in this audience know, that RAN evolution is going into two different architectural dimensions or transformations. First is the disaggregation, RAN or RAN centralization, which can be called disaggregation or split baseband functionality, which is a 3GPP specification for 5G RAN, which can be used on for 4G RAN as well, and is being used. So split the functionality of the base station in different entities, which we know of here, but I will talk about that a bit more. And the other dimension is RAN cloudification, which is separation of hardware and software on two of the three entities. And this is, of course, where we as Red Hat step in and play in and work with our radio vendor partners to cloudify part of the disaggregated base station. Now, Telecom Infra project was mentioned, which is playing a big role and major role on this domain, including their, I think, 13 or 14 community labs around the world, Indonesia being one of those. Oran Alliance as well, playing a major role for looking at the architectures of how this thing will be built and interfaces within this architecture. Now, the terminology in this space is kind of confusing. So there's an active link at the bottom of the slide. When you get the slides, you can look at that short blog which I wrote a couple of months ago, trying to explain what ORAN means, what vRAN means, and so forth. So I have a very short kind of overview of what those means. But before going there, I try to kind of illustrate what this transition might look like. This is not, of course, a detailed, hopefully accurate though, representation of how this transformation looks like. And I've been using this mainly for educating Red Hat folks internally. You know, Red Hat not being a radio company, but trying to illustrate how this looks like. So left-hand side is a traditional 4G base station or LTE base station with a lot of stuff on the cell side. Of course, mast is there and antennas, they need to be there, remote radio head, maybe microwave links and all that stuff. But then the interesting thing is the BBU on the bottom of the mast baseband unit, which is fairly high-end device from compute capacity point of view, from memory capacity point of view. It eats quite a bit of power, electrical power, and all that stuff, because it's a complex thing and it has to execute complex algorithms, including this famous X2 protocol between the base stations directly to manage the handovers and manage the radio interference control and timing and synchronization, and you name it. So it ended up being a very high-end computer, if I may say so. And there's many reasons which led the 3GPP standardization to work on the split functionality. And one of the reasons, or part of the reasons, are to make the base station cell site simpler than they used to be by separating these things from each other and making it possible that the baseband unit functionality, which is now divided into two different entities on the right-hand side, the green boxes, the distributed unit next to the base station and centralized unit managing the DUs. So those things can be now taken out from the cell site and making the cell site as simple as ever possible. Of course, there's still a lot of stuff on the cell site which never can go away. Mast, antenna, radio unit, which is the 5G terminology, and all these things. Now, important thing is also, of course, the interfaces between these entities, and the front haul interface, open front haul, is an ORAN alliance work between radio unit and distributed unit, and then 3GPP has been working on F1 interface, also known as mid-haul. Now, the cloud platform can be now applied to DU, to host DU and CU, the same cloud platform, and that's very consistent of what Red Hat is doing to provide the same platform for each entities. Of course, the platform functionality or the requirements of what the platform has to do, they are quite different when comparing to central data center and core networks and the CU hosting cloud platform and the DU hosting. But we have been still able to do and implement only one implementation of our platform, which has high degree of configurability for different purposes. Now, the other interesting thing is the edge data center. So the centralized unit can be hosted, or that location can be called edge data center, and it's well possible, which is happening as we speak, that the operators are hosting other workloads on the CU side, on the same cloud platform than the CU. And that, of course, makes a lot of sense from economies of scale point of view and all these things. But the DU side cannot be edge data center because of hard requirements of the cloud platform and DU, real-time requirements and hardware accelerators, but also because the radio stack is terminated on the CU. So the CU is the first location when we can have the local breakout. So CU site can be considered as an edge data center. And as I said, many people are doing that as we speak. Now, I'll go quickly through these, which are described in detail in my blog, which I advertised earlier. So the first diagram is the same three-entity division, RU, DU, and CU by 3GPP, running on their own environment, having an interface between them. And the interface between these, it can be proprietary. It doesn't need to be open. And this is the model which we have seen in, I don't know how many 5G radio network deployments there already are globally, probably like 150 per each major vendor, like Ericsson and Nokia and Huawei and those guys. And they are all pretty much all single vendor 5G radio deployment so far with no open interfaces. So that's the upper model here. The lower model on this slide is to apply O-RAN open front haul and 3GPP F1 interface. So you can then call that this is a open RAN. Of course, there are tons of other interfaces O-RAN alliances specifying, but these are the main two between the radio workloads. So you can call this open RAN. I call it open RAN. It's not an industry standard term, but just to make it a little bit clear. And then the upper part of this slide I call vRAN, virtualized RAN. And as you can see, the RAN workloads are not having open interfaces in this model, but applying DU and CU sites are applying a cloud platform, which can be virtualized platform, virtualization platform, or container platform, either way. Today, it tends to be more and more container platform on bare metal than virtualization platform, but it can be either way. So that I call vRAN, because this is still, from radio workload point of view, it's still a single vendor thing, because there are no open interfaces between the entities, but it's virtualized, or DU and CU virtualized. Radio unit virtualization of the radio unit, I am pretty sure we will get there one of these days. We are not there now, but I'm sure we will get there one of these days. At least applying a container capable Linux distribution of some kind in the radio unit. That's going to happen, but maybe not quite now. The last one on this series on the lower graphic is a combination of the previous, and I call it open vRAN. Again, not an industry agreed term, but trying to clarify what this means. So open vRAN in my diagram is having open interfaces between the workloads and open interfaces within CU and DU, which I only show the famous O2 interface, which is the only O-RAN interface which touches what Red Hat is doing. So this can be called open vRAN. And to show the complex thing of the O-RAN, this is one of the O-RAN diagrams from one of their white papers. And the only thing I have added is everything which is on dashed lines. So 4G line on the bottom, 5G line with the same entity division, RU, DU, and CU. And then the red dashed line box is the cloud platform potentially hosting DUs and CUs, and also near real-time RIC running the intelligent controller. And as I said earlier, the only interface which touches Red Hat is the O2, which is under development right now. And people who are involved and knowledgeable of O-RAN Alliance know that it has been a very, very controversial discussion of how the O2 interface should look like. Initially, O-RAN started to specify O-RAN O2 interface, from the beginning, from the scratch. And we stepped up as a Red Hat, and a few other companies stepped up and proposed that maybe better idea is to take what the Kubernetes open source community has as management interfaces, which is not perfect match what Oran wants to do, but it would be a good base, not to start from the scratch, but take that as a base and then make a gap analysis and fill in the gaps. And luckily, many people agreed to that approach. And just recently, like a few weeks ago, 2 or 3 weeks ago, we made a joint proposal with Ericsson and Nokia and Red Hat to Oran Alliance how the O2 should look like. And it's getting a lot of or more and more support as we speak, which is good thing. Now, a little bit on requirements to the cloud platform, because I am still talking about cloud platform, not random workloads. I'm sure Kundan will talk about RAN workloads in his presentation. So real-time kernel or real-time execution environment is a must on DU. We don't need it on CU. It's a must on DU. There are a couple of RAN vendors who do not necessarily need real-time execution environment, but most of the people do need that. Timing and synchronization is an interesting topic, and why I am talking about it as a platform vendor. There's a specific reason for that. The reason is that the Oran Alliance, in their architecture work, they have decided that the timing and synchronization chain is on the responsibility of the cloud platform, and it is decoupled from the RAN workloads, which is the traditional method. So that's why we as Red Hat, we are working on timing and synchronization, on precision time protocol, sync-E, and everything which comes with those things. And we have presented our approach or our model and achievements in 3 international conferences so far, and will be in the International Timing and Sync Forum again this fall, which might even be an in-person event in UK. That would be cool. Hardware acceleration, again, on DU, we need to have access. We need to be able to provide access to hardware accelerators for the RAN workloads, like Altiostar DU logic. And we do that with FPGAs and GPUs and whatever you might have. So I think I'm gonna not talk about it. We are a bit of behind the schedule, but there are tons of other requirements which are put on cloud platform when we compare what cloud platform has to do in central data centers. So these are all RAN related, CU and DU related. A lot more on DU related, but CU related as well to some extent. And these are the models in our Kubernetes container platform called OpenShift. The models, deployments model we need to support for RAN use cases and other edge use cases as well. And those are shown on the left-hand side. So on the edge side, we can have an OpenShift 3-node cluster, which is a typical Kubernetes configuration in OpenShift as well, and other Kubernetes platforms. So 3 servers having supervisors and worker nodes on all 3, which of course can be expanded. Then the middle model on the left-hand side is, we call it single node OpenShift, which is a model where one single server, we can install OpenShift and the workloads on one single server on the edge side. And of course, we need to think about what that means from high availability, service availability point of view, but that is a hard requirement from many of our customers and big and our RAN vendor partners as well. And the third model is called remote worker node, where we can remote single worker nodes, single servers running only the workloads outside from the OpenShift cluster, management cluster, which is in the middle. And the OpenShift can today manage up to 2,000 remote worker nodes, which is it's a good number, but it's not sufficient for really big RAN deployments. The other models, there pretty much is no upper limit how many we can support. All right, and this is the deployment models, how the cell site might look like. You know, we talked about that already. So cell site can have still all entities deployed, RU, DU, and CU, or only RU and DU, or only RU, and then centralize the rest. And how the cell site will be built is dependent on many different requirements and characteristics and factors. And those are mainly outside of the scope of what Red Hat is doing. But from our point of view, again, the red bar, the cloud platform, is visible in all of these places, so we can host any of these workloads still, whether they are on the cell site or edge side or regional site or anywhere. And that really describes our horizontal telco cloud for all use cases. How the cell site is being built, it doesn't really matter to us, but we just have to support all these different models. There is no doubt. Okay, and then the other thing, kind of complex diagram, but and a lot of this on this slide, the latency numbers and the geographic distances between the entities. Again, that's not much of Red Hat business, but we still need to understand all these numbers, because the latency over all chain, whether it's a network slice or something else, the latency budget is divided between all the entities on the way, including the platforms on the way. So we are typically allocated a number of microseconds or milliseconds, whatever is the situation. And so we need to understand and know where the end-to-end latency budget comes from and how much of that is allocated to Red Hat. That's why we try to be completely on top of these standards on the latencies and real-life deployments on latencies, and even look at the transport network latencies on the bottom of the slide. But most of these things, they are not in our domain, but we still need to understand exactly what is happening. The little bit of different management view of how different cell site models or RAN models can be built based on Red Hat offering. So no more on that. I'm going to go quite quickly through the rest. So accelerators I talked about, and we need to support a fairly large number of hardware accelerators for DU purposes only, and then some other purposes in other use cases. And here I have only a couple of examples. And again, as everybody knows, the Intel FPGA N3000 is the most widely used hardware accelerator on DU as we speak. So that is fully supported in our product with Intel provided operators, not the service provider operators, but Kubernetes operators, which can configure and manage the N3000. And Intel is also building the Kubernetes operators for Mount Price eASIC accelerator, which is being worked as we speak. Then we support NVIDIA GPUs. I know I will not go to this slide at all right now, just to mention that we do support NVIDIA GPUs for DU and other workloads. We have just released a completely new version and model how that is done. So this slide is not very valuable anymore. But just to mention that NVIDIA is one of the accelerator partners we have. Then a bit on the timing and sync, my favorite topic. So as I have this yellow box on the upper right-hand side, it's interesting that Oran Alliance has taken this approach that the synchronization is responsible of cloud infrastructure and decoupled from the RAN instances, which of course creates a lot more work for us, but it's absolutely interesting work and important work to be done. So I don't go through these different synchronization models, frequency, phase, and time, other than just saying that we need to support all of these different things depending if the network is a frequency division duplex or time division duplex network. Now, to just highlight the challenge of RAN synchronization on one slide, I have this map of US, and this is a plot of from Verizon network based on public data. So everything is public, which has been plotted here. And it has about more than 500,000 cell sectors and hundreds of thousands of network elements in this network, in this map. And the network elements need to be synchronized down to 1.5 microsecond timing error between each other throughout the whole network. So that kind of explains or describes on high level what the challenge is. But of course, there is a solution, and solution has been there for quite some time. But the timing accuracy requirements are obviously getting more and more tight when we go towards 5G and millimeter wave and 6G and all these things, beamforming and all those things. So this is kind of interesting thing, again, from the pure open source software platform vendor point of view, that we need to deal with these kind of things. But it is what it is. And as I said, it's highly, highly interesting. Now, these are just to mention Oran Alliance specified timing profiles, low-level split timing profiles, which we are not supporting every one of these different configurations today, but we support quite a bit, and we add the support to new configurations as we hit the customer case that the customer decides to do a specific timing and synchronization configuration, and then we just do it. But we have a good base there already. Then, yeah, so this is how the precision time protocol stack looks like in Linux kernel and user space, with virtualization, KVM, or without. So KVM module can be bypassed if we are talking about the container platform without virtualization. So no need to go into the details. And just an example of how we just put the OpenShift container platform into timing and synchronization chain. And this is just one example, which is the ORAN C3 profile. So no need to go there. Real-time kernel a little bit. So a couple of slides on this. So we have a method that we can partition a multi-core CPU, x86 CPU. We are of course talking mainly. So we can partition the x86 CPU cores into real-time cores and housekeeping cores, as we call it. So that we can run on one instance, we can run both real-time workloads like DU workload, but we can also run non-real-time kind of generic workloads on the same CPU socket or same CPU once we have done the CPU of the core partitioning. And a little bit on one example of, or one instance of our measurements on the real-time latencies, which numbers satisfy all requirements we have heard from RAN vendors and big service providers. China Mobile, for example, is a very active, has been very active and is very active on measuring this thing, and we can satisfy their numbers. No, so I don't go through the numbers. I'm just saying that the minimum scheduling latencies are important. Average scheduling latencies are important, but max latency is the most important thing, because max latency is the number which can never be exceeded. And if the system exceeds the max confirmed latency, then the system breaks down immediately. So the max latency is the most important. And in my diagrams, in the upper table, the max latency is 10 or 9. So 10 is the number we say that we don't exceed. And then if we disable the hyper-threading, we can go down to 8. So these are the numbers which cannot be exceeded in any instance. That's important. Again, minimum and average are important, but max is the thing which means the most. So I talked about the Kubernetes operators a bit. So we have been building a lot of operators. Intel has been building the workload vendors who are onboarding their workloads on OpenShift. They typically build an operator which comes with the workload itself. And the operator is typically used for installing, administering, upgrading, and all these things of the workload. So one of the most important operator in this RAN space is, as we call it, performance add-on operator, through which we can, or the user who is installing these things can configure the enhanced platform awareness features, huge base, CPU pinning, real-time, SRIOV, and whatever you might have. So very, very important operator. And operator concept itself is, the Kubernetes operator concept is highly important and highly valuable for any workload vendors and any accelerator vendors, and pretty much anything. Okay. SRIOV, we don't need to talk about it. That has been around since the beginning of network function virtualization 8-9 years ago. Direct access to hardware from the workload. Multi-network interface to containers is a must. So initially, the Kubernetes container platform only supports one network instance for a container. And that is obviously no go in telco networking when you need to have incoming GTP tunnels and outgoing GTP tunnels and connection to policy control and whatever. So this Multus open source project add-on project to basic Kubernetes provides a number of network interfaces for a single containers, and that is a most widely used multi-NIC open source project. There are others, but Multus is the most important, and we have done that a lot together with Intel for quite a while. Now our RAN ecosystem very quickly. So we work with pretty much all RAN vendors. Altiostar, I have to say, is with which we are the furthest, and that's obviously because of the Rakuten case, which we both are part of in Rakuten 4G. So we started to work with Altiostar already quite a few years ago, and we are now building a complete automation facilities and functionality to RAN deployment together with Altiostar. Then we work with other RAN partners as well, and so forth. So no more on that. Now, my last slide, I think, is just to point out that we are making a major investment into telco, the telco segment of Red Hat as a company. Hiring a lot of partner engineering for telco and building this this major lab. It's a major lab for Red Hat standards. It's not a major lab from some big company standards, but from our point of view, it's a major investment, and it's being built as we speak to Massachusetts, where our main R&D facility is in US. And it even includes the walk-in Faraday shielded room for housing the radio equipment and all that stuff. Just to point out that there's a major investment going on. And I think that's about it. That's my part, and I'm gonna hand over to Altiostar.
Okay, thank you so much, Mr. Chukiaho, for your presentation. Yeah, this is amazing, learning us about the Open RAN ecosystem and how the Red Hat could be very powerful in this telco industry. So you give also so many use case and experience sharing from the live network. Again, thank you for your presentation, and for everyone who will have the question for Mr. Chukiaho, please feel free to write it on the chat line, and later we'll catch it up again after we hear the presentation from Mr. Kundandes. Okay, so hello, Mr. Des, are you ready to give the presentation? Hello, sir. Still in the mute, I think. Hello, sir. Is it okay? So unmute.
Can you hear me now?
Yeah. Nice. Nice to hear your voice, sir.
Thank you very much.
So I will bring your slide later on. Yeah. So without further ado, I would like to introduce you to the second distinguished presenter for today, who is coming from the Asia Pacific ANZ Altiostar, Mr. Kundandes. He will bring the presentation entitled 5G and Open RAN Strategy with Public Cloud Integration. So please, Mr. Kundandes, the time is yours.
Right. Thanks, everyone. So thanks to Timo again. So Timo has covered most of the stuff, and I'll try to avoid any kind of overlapping. And I'll focus my presentation primarily on the Open RAN front, further integrating to the cloud, and particularly the adoption that operators are going as a combination of 5G and Open RAN with cloud integration, and more focus eventually going to be the future networks, which are more on the public cloud, which is just starting its initial steps. So go next. So as you know, like we have gone through the pandemic, like I can't say we have gone through, but we are in a pandemic year. So how in pandemic, the situation, particularly in the context of network, that has changed. So whenever we design, deploy, plan a network, we plan it with respect to certain capacity, okay? The capacity, what is estimated, and based on that one, we offer the capacity. So if you look at in a mobile network, what we have seen, the capacity has grown up in this pandemic, particularly like when we have to design or deploy the network, we have to fit into the maximum demand of the network, okay? So the maximum demand used to come at 23 hours at night, and then it comes down in the morning time or the night time. So what we have seen is that the maximum demand has gone up by 75%. Now that in turn has further accelerated a investment because the traffic need to be catered for the maximum demand. But the but typically in the past, what we have seen is that the peak demand always goes up. But in this particular scenario of the pandemic, what we have seen is that it is not only the peak, but overall utilization of the mobile network has gone up quite a lot. And this is a data that I have taken from one of the leading operator of the world. Then the data growth has not only happened in terms of the mobile network, but it has also happened in the fixed network. But in case of mobile network, the adoption and the growth is much higher than in comparison to the fixed network. Now, obviously, that need to be further linked with what is the demand drivers which are boosting this particular growth in the data adoption. So there are various drivers, particularly for consumer and business, 4K video, then enterprise cloud, cloud gaming services, big data analytics, consumer IoT, financial services or fintech, as you have seen that, particularly like in Asia Pac, there are a number of fintech companies of late have done really a great job. And particularly in the pandemic, when it is the online e-commerce sites and fintech, they have integrated. So we have seen in Indonesia, like Grab, Gojek, the kind of business they have done is exceptional, and it has grown exponentially in the last 2 years. Then downloading of cloud file storage, video calling, AR, VR services. So all these are various kind of demand drivers, which is now transforming the overall network capacity from a traditional growth pattern to a completely extraordinary growth pattern. Now, when this growth need to be further fulfilled with investment, we have to also consider, or particularly the operator has to also consider both investment, quality of services, automation, all the best of the practices together so that the experience to the end user is going to be really good. So what you're finding is that a lot of new things which are coming up. ORAN is one of the thing. In Asia Pac, we have seen particularly Indonesia with the support of TIP. It has really made good entry in the ORAN. At least we have started again seeing operators coming extremely innovative idea of putting their overall network requirement in place, integrating ORAN. So as you know, in ORAN, you go for splitting the hardware to software, but particularly from Indonesia, to manage the cost, improve the capacity, we have seen operators, they have gone quite innovatively in splitting not only hardware, software, but services, servers, everything in a very, split manner. And individually, they are working out a cost optimization of that particular component. And further, everything is going to be integrated by a system integrator. So everything remains open in the requirement. That is a great learning. Possibly, we have to, our operator have to see from Indonesia market and Indonesian operators. Moving next. Can you go to the next slide? So this is how adoption of Open RAN has happened. Of course, Timo has given great details of Open RAN. So this is a traditional network, which is where every interface, every hardware, software are closely stitched. And Indonesia has experienced that particular complications for the last number of decades. And this is the first time we are finding in Indonesia, operators have gone for distributing each and every component, including hardware, software, services, servers, virtualization, everything, talking differently. They are putting a lot of efforts to optimize the overall cost and further invest into capacity and build up a completely open network that is next generation centric. So if you look at the Open RAN model, everything is open, it is further containerized, and overall benefits are going to be realized, or the benefits are multifold for operators. There are operators who may not be interested of going into that, but the fact remains is that if we go back to the history, whichever technology has adopted openness have gone benefiting the customers in multifold than a closed architecture or a closed network that is deployed. Going next, go to the next slide. So this is on the Open RAN front, another slide which we have deployed in one of the largest Open RAN network deployment in Japan. If you look at in today's context, most of the closed network, they have their own hardware and that runs by their own software. But here, if you look at the operator has only a single software and multiple hardware, okay, that is running using the software, this software that is coming from single guy. If they don't like the hardware, they can anytime, or if a hardware is not performing up to their expectation, they can anytime change that hardware and bring in new hardware, but it is going to work with the software. So that is the kind of flexibility which previously operators or operators even today who are based on closed architecture, they have not able to go with, but this operator has gone with. Now, coming to the, and when you actually deploy such kind of network, you not only able to get the benefit in terms of flexibility, but you also get benefit with respect to the overall total cost of ownership benefit. You correlate this particular model with two different business. One is the computer business or a laptop business. You get any laptop, you can work with Microsoft Windows software. You get any Android hardware, okay, which is phone, and Android works in everyone, okay. So if you look at those two industry correlating with the base station right now, how they got benefited, they got laptop from the range of, let's say, $3,000 to even $300. The same thing for phone, it has come to less than $100 to again $1,000. So at each segment for each kind of customer, there are different hardwares, value propositions are added, but the software remain common and the software is flexible. You do not concerned about whether it is going to work or it is not going to work. Okay, go next. So that is the kind of flexibility what Open RAN has bring to the network. Now coming to the cloud computing in the telco domain. So what we have seen is that on the stack components of the cloud services, we have application development environment, and virtualized infrastructure. Now the virtualized infrastructure, if you correlate back to a Open RAN network, it is a combination of storage and servers. Then if you go to the development platform and the applications, those remains primarily the virtualized and software applications, including AI, ML, those kind of functions. Now, if you look at in this particular model, it closely, typically in the past, the mobile network, they don't do business based on the uh, IaaS, PaaS and SaaS based model. But today, those things which used to be on a data center or a cloud centric architecture is well integrated to a operator's overall commercial and investment model. So that itself is going to give a lot of benefit and direction for the operator, what to invest, what not to invest, and how the cost is going to be distributed, not only by everything is going to be your own capex, but it will be also shared by different ecosystem partners. Go next. Can you go next, please? So if you look at the adoption of cloud computing, so we have infrastructure modernization, IT operation, automation, public cloud, then hybrid cloud. It can be on-premises, it can be public cloud, but there is a close match is now coming between the telco and the hyperscalers, which are coming from the industry, and jointly they are complementing each other and delivering value to operators. The operators are able to realize what traditionally enterprise able to realize on their investment and innovation now in operators network. That is not only for the new areas like AI, ML, mobile edge computing, caching, optimization, orchestration in those areas, but also in the traditional areas like access, where the, the distributed unit and the centralized unit, everything apart from the radio can be virtualized and be taken up to a cloud. And the cloud can be a public cloud, okay, or it can be a hybrid cloud. So that is what we are focusing and what we are confident that in future, that is how things are going to evolve. Go next, please. On the adoption front, if you look at on the mobile network, okay, so it is an API RAN, which is less matured, network slice, IoT. So if you look at the OSS, BSS or the core component, that is more virtualized, like for example, EPC, OSS, BSS, PCRF, HSS, they're more virtualized. Then it has now started going to edge compute, combination of public cloud as well as virtualization. Then eventually it is moving towards RAN, further evolving and integrating the RAN components, both from the hardware and software point of view. So with this, there are 5 different models that are coming out for operators. One is a traditional or classic vendor telco relationship. Second is network as a function as a service. Third is network oriented platform service, PaaS. Network as a cloud platform, NAP. Then network as a compute model. Now, these are the 5 different options that a operator is finding when it is collaborating with the hyperscaler moving towards the cloud. Go next. So these are the 3 examples how they have gone ahead with. In the US, DISC is the operator, which is the 4th operator with all of the US presence in terms of licensing. They have gone ahead for network as a function, which is up to the access, network as a cloud platform. Then Orange is working with Google Cloud, that is telco oriented platform as a service. Then Azure and AT&T, they are working as network as a compute. So in all of this manner, what we're finding is that the adoption of both software as well as network hardware are closely now integrating with private cloud and hyperscalers. But the critical component here is that the overall TCO, depending on the adoption, goes down aggressively for operator. The operator is able to get support of the cloud providers in deploying the network faster. There are various use cases which are more customizable for enterprise than consumer is going to be well integrated with this kind of cloud model, because the cloud guys are closely understood the enterprise application and business model, and that is what they're trying to bring as a value for the operators when they're going to work together. Please go next. So this is one of the example further I have thought of detailing out. This is AWS working with disk. So if you look at in this particular architecture, so AWS has 3 different options. So one is the outpost, the second is the local zone, then the AWS wavelength. So if you look at here, what AWS has done is that they have taken completely the hardware whatever operator needs apart from the radio is now based on AWS. And it is the software which are hosted on the AWS platform and offering the end-to-end network. So it started, if you look at in April 2021, but it has quickly got momentum, and we are finding that it is showing results on ground, particularly in commercial deployments. The actual value it is going to bring in once it is goes further, not only in the consumer network, but more on the enterprise network. And enterprise network is a key area for 5G innovation, which was still not tapped even by 4G. So with this particular architecture, you work on the latency management, the virtualization, the coming closer to the network. So all the benefits, whatever are needed from the network, are complemented between AWS and disk as a network. And we are proud to say that Altiostar is one of the partner in this particular deployment, working closely with Disk as well as AWS. I think with this, I will finish my presentation. I think the slides are over. Can you go next? Yeah. So thanks to everyone, and thanks to Timo in specific, because Timo and Red Hat, of course, they're a great partner to us. And when I saw Timo's name, I could not say, I aligned all my meetings and, wanted to be here. Timo, thanks your presence. And of course, I know, like last I have seen you in the India conference. Okay. So thanks everyone, and thanks the university and the student and anyone who has joined the webinar. Yeah, what's next to do now?
Okay, thank you, Mr. Des. It's such an extraordinary presentation, and also the interesting use case, to work closely with the AWS or Azure on the telco network. And this will bring us the awareness on how Altiostar help us to support on this deployment and development on the Open or 5G network now. Maybe on later on also as well as Red Hat, Mr. Timo, and then I hope later on also we could have the use case test on the IP Community Lab at Telkom University. So yeah, again, thank you so much for your enlightenment. So now we go to the next session. Yeah, I think it will be the question and answer. Yeah. So for everyone who want to have a question to our distinguished presenter, please feel free to unmute yourself, and so we can hear your voice maybe. Yeah, and we can discuss directly about the very interesting presentation matter for today. Okay. So I think one question from chat line that is from Dewi. She is asking question to Mr. Das about that. Can you explain more the definition for each 5 business model with hyperscale?
Okay, so let me just go back to the slide.
So do you want me to?
No, that's fine.
Oh, okay.
Yeah, so if you look at cloud is something which is not new. Okay, that's the first aspect. So some of the other, applications a operator used to have, or for that matter, a operator is also an enterprise eventually. So they, like for example, the operator has a financial service, okay, and that financial services are running on, let's say, Salesforce, which is a cloud application, okay. So that's a typical vendor telco relationship. Now, as you move to as the cloud was moving to the network side, okay, the network function as service. So previously it was software as a service. Now the network is coming as a service. Like for example, a operator, standalone operator, they have their own packet core. Okay. Now, what exactly a packet core in a 4G network? If you look at it, is MMES gateway, P gateway. Now that MMES gateway, P gateway, you have to invest your servers, softwares, everything, and offer the service. But now what possibly can happen is that you are not going to invest anything related to the servers. The servers are available in the cloud. So Ajay, if you go back to my first slide, the traffic, the way it is growing. So as the traffic growth happens, you need, let's say, for example, you have planned a particular traffic growth, and based on that, you have deployed number of servers. So all of a sudden, the traffic has gone up. Now you can scale within a span of 3-4 days to cater to that particular requirement. So eventually what will happen is that if your numbers are not growing, the network is going to face congestion. But when you put it in a data center, okay, and the traffic growth happens and it is virtualized, so you get on-demand based server capacity from the virtualization or the or players like AWS and all. So they give you that particular capacity on a instant basis or on a short-term basis. And if you need them permanently, because after having the experience good, you will not try to further bring it down. So if you got that particular benefit with the elasticity provided by the cloud company, then you'll try to further expand your relationship with the cloud company, sourcing the capacity from them rather than investing your on the data center or on the server. Then the third model is that techno-oriented platform as a service.
Did we lose him?
Hello? Yeah, I think we lost Mr. Das. Okay, do you have any additional information, Mr. Chukieho, for the audience?
No, not really. I wonder if there are any questions for me specifically, but
oh, okay, sure.
Yeah. I think we covered things nicely.
Yeah. We can go to the next question. I think Muhammad Lutfi, I think you can open your microphone.
Okay.
Please. Thank you.
Thanks for the TIP Lab from Telio and Tech Bros for provide the webinar. Tell me about me. My name is Muhammad Lutfi. I am an undergraduate student from Telkom University, Bandung. Okay. I want to ask for Mr. Timo. I have two questions. The first question, I want to ask whether what is presented is still in research stage or has it been implemented on commercial? That's my first question. Okay, the second question is a technical question. Recently, I tried OpenStack for service function chaining. Basically, container or virtual machine performance worse than bare metal because it uses PCPU or allocation ratio. How to solve this so that performance remains good? Do you use CPU pinning or NUMA nodes or other? Okay, my question.
Yeah. Okay. So the first question, yes, everything I talked is completely commercial and in production in even large scale deployments, both on core and very quickly going to the RAN as well, the disaggregated RAN. Now talking about the container platform OpenShift. And the same applies, of course, to Red Hat OpenStack, which we used in network function virtualization over all these 7-8 years. So we do have probably 150, 200 OpenStack NFV deployments globally. And OpenShift as a container platform on bare metal is now getting there. So it's all commercial, and the journey to the containers is starting, but we have many live deployments in production. But having said that, of course, these products, they are developing all the time further, new features added, new functionality added, more hardening security features added, and so forth. So that's obviously, like in all software product development, it's an endless cycle to just make it better. But it's all commercial. All right. Now, the performance issues So it's a kind of interesting history. You mentioned NUMA or virtual CPU pinning and NUMA awareness and all these things. It's an interesting history in open source communities, because we had to, not just Red Hat, but together with Intel and together with Ericsson and whoever, we had to convince quite a few open source communities to adopt these things like CPU pinning and SRIOB and whatever you might have for the networking performance enhancements. And why it was so difficult or challenging, well, good thing is that it all happened at the end, but why it was so challenging was that the OpenStack community and Kubernetes community, they really did not understand, why do I need to kind of lock my application to the hardware, because this is cloud computing. Why would we do that? But they realized and understood at the end that if we don't have CPU pinning, if we don't have NUMA awareness, if we don't have SRLV, this thing is not going to fly in telco network. So those features are used extensively. I mean, really extensively, because of performance issues, as you pointed out.
Okay, thank you. I have one question again. As I know, ASIC from Intel Tofino is used for the network acceleration interface. Do you use ASIC to support the programmable network like P4 in Oren?
Yeah, so P4 is another interesting kind of a neutral technology by which you can offload your networking functionality from your main CPU to the accelerators. So we support P4, and we work with our partners like, I don't know if you know a company called Kaloom. Kaloom is a company who is using our technology embedded in a white label switches, which we can program with the through the P4 interface to kind of offload the main CPU and put the networking functionality into white box switches and hardware. Yeah, P4 is good, important, and maybe not very widely used, but it's getting more and more attention as we speak.
Okay, thank you, Mr. Timo and Red Hat for the troubleshooting documentation. It helped me. Thank you.
You're welcome.
Okay, thank you so much, Pak Lutfi. Yeah.
Sorry, I was
Mr. Das?
disconnected.
Oh, okay.
Come back.
Oh, yeah. I think you can change it back again. So this next question from Devi again, Mr. Timo, yeah. This is for Mr.
Sorry,
Timo.
Pak. This is Dewi. Maybe Pak
Yes, maybe you
can continue the
yeah?
answer.
So
I mean, for the previous question, maybe Pak Das can continue the explanation, Pak. Before we move to the next question to Pak Timo.
Okay, Pak Das.
Is it for me? Okay, so I think I told, like, the things which were the kind of flexibility, okay, each of the model that gives, that is quite different, okay, and that needs different kind of engagement between the operator and the cloud provider. Some of the models are quite generic or simple, and some of the models are quite, critical. Like, for example, when you outsource or when you offload the entire network to cloud, then probably you'll ask questions related to security. Okay, so it is a valid question as an operator, and it is also a valid assessment and deliverable need to be provided by the cloud provider. So what I mean to say is that by adopting the entire range of options or business models for cloud migration, the operator is definitely going to be benefited. There is no doubt about it. However, it is also need to be done that the validation of your key concerns, which are maybe of your own or maybe country regulatory point of view or everything. So that is also need to be taken care of. Okay, like for example, let's say in Indonesia, you have a requirement that the network cannot be login from any other country than Indonesia. That means ideally the cloud provider should have a dedicated network of data centers and software and applications residing in Indonesia, and need to have enough isolation between the internet and the private cloud. So those are the things which are critical and need to be well assessed before any adoption. I hope I answered the question.
Okay.
Okay,
How
Pak.
was it, Bu Dewi?
Yeah, or maybe
Nice.
a little bit need more explanation, Pak, for the difference between the telco-oriented platform as a service.
Sure, I will share my email address and yeah, we can be in touch with.
Okay, thank you.
Okay. So next for the next question, maybe you can speak it out directly, Miss Dewi, to Pak Timo.
Okay, thank you, Pak. So
Nice.
next question is for Pak Timo. I already type it in the chat. Okay, maybe I can ask it directly to Pak Timo. I have like a 3 question, Pak Timo. The first question is for the SMO. In your slide, there is like the high level run stack, yeah, the architecture, and there is like the SMO, service management and orchestration. Then the question is, from where this SMO, Pak? Is it from the Red Hat? I mean, is Red Hat provided also, or comes from Open Run vendor? And then the second question, because you explain about Red Hat solution and Pak does explain about the cooperation with the hyperscale, then I'm a bit curious whether Red Hat solution also being used by the hyperscaler, or this hyperscaler use their own solution for the infra, maybe like the OpenShift used by the hyperscale, or hyperscale have their own solution, something like the OpenShift, OpenShift. Then the third question is, do you have the experience to deliver edge infra solution that collocation between the radio, UPF, and MEC, or the application? Because I saw before in your slide, there is like the cloud platform, then on top of it, you have like several scenarios, which that show, one of it show that it has like collocation between the radio, UPF, and also the apps, or maybe like the edge apps, something like that.
Yeah, okay, so number 1, service management and orchestration, which is an O-RAN Alliance term. No, Red Hat does not have that product. We do not have it. We provide the cloud platform on top of which the SMO can run, and we rely on our partners to provide the SMOs. And examples of the partners are Netcracker and Amdocs and IBM and some equipment providers. But we do not have SMO, and we do not have plan to have an SMO product. Actually, the same applies to NFV orchestrator. We do not have that either. So we rely on our partners on that domain. Second question, it's an interesting question about the hyperscalers. So all the hyperscalers, if we talk about Microsoft Azure and AWS and Google Cloud Platform, IBM, Alibaba, all of those guys, they do have their own cloud stack, which they provide, which are not the same, and they are even not very similar. So they do have their own cloud platforms, but interestingly enough, we partner with every one of those, which I mentioned. And what's happening quite a bit is that our OpenShift Kubernetes container platform can be installed on top of every single hyperscaler stack. And what that means is that if you have an application which is running on Red Hat OpenShift, you can provide we can provide portability between the hyperscaler stacks for the application by having the similar OpenShift installed in all of those. So that's our model, and it's been on IT side specifically, it has been adopted very, very widely, that OpenShift is running on AWS or Google Cloud or Azure or other places to kind of provide a portability functionality to the application. And the third question is the co-location of radio, UPF, and MEC. We don't have, if you mean radio as a radio unit, we do not have that, but we do have cases, and Rakuten, again, together with Altiostar, is a good example of co-locating centralized unit and UPF, it's a Cisco UPF in that case, and edge compute functionality on the same site. And that is because it's done a few years ago, it's still Red Hat OpenStack, not OpenShift. But the functionality is that you have the cloud platform OpenStack, you have Altiostar centralized unit, then you have Cisco UPF for local breakout, and then edge applications from Rakuten. So that's a good example, and those are now being built based on containers as we speak, but they're quite in early phases and cannot talk too much about those, but it seems to become a very popular use case, which I completely understand from economy of scale point of view.
Yeah.
Thank you for the answer, Pak Timo. Maybe a bit curious for your answer for the second question. You said that we can onboard the OpenShift in the public cloud. So
Yes.
Is it virtualization on top of the virtualization? But I cannot imagine about it. So what's the objective to have like the OpenShift on top of the cloud in the public cloud?
So the objective, how would I say? So the objective for the end customer, whether let's say it's a big telco, Deutsche Telekom is a good example. It's a big telco who have developed applications on OpenShift, on premises OpenShift. And then they have a reason, or they have a demand or reason to use public cloud for that same application. So what they need to do, they don't need to do anything to their application. They just install OpenShift to public cloud, and their application runs automatically. So it's a kind of an application portability issue for the end users or the application developers. That's the use case. And as I said, it's quite popular on IT application side specifically. Telco is coming as we heard from Altiostar in Dish case. It's telco is coming, but it's very popular on IT side.
Okay, I understand. Maybe when we onboard the OpenShift in the public cloud, maybe we use the public cloud only for the IaaS, IaaS function, as the IaaS function.
Exactly.
And then the platform function is come from the OpenShift,
Yeah, exactly.
Okay, thank you, Pak.
Pleasure.
Okay, thank you so much, Mr. Timo. Anyone have another question, please? Yeah, please. Okay. So yeah, this is a good opportunity for us to have discussion of the new technology and then on how the telecommunication technology now turn out from the traditional to the next future technology. So I think we have please everyone who attend this meeting can click the form which we send it to the chat. Yeah, to take the list, yeah, of somebody or everyone who has already joined this meeting. So I think if there is no question, we will resume it. Okay, so no one. So I think yeah. So Altiostar and Red Hat can provide 4G and 5G open virtualized RAN, yeah, software that supports open interface and virtualize the baseband unit to build a disaggregated multi-vendor web scale cloud native mobile network. And the operators can add intelligence, quickly adapt the network for different services, and automate operation to rapidly scale the network and reduce the total cost of ownership, yeah, it's called TCO. Yeah. So we are engaged everyone to collaborate in the growing ecosystem of partners to support a diverse open RAN supply chain, and also later on to deploy and develop the network, especially in Indonesia. Yeah. So I think before we end this webinar, we need to have some memory together. Yeah. Can we share the camera so we can take a picture of all of you together, please?
You know, my picture is not coming, so.
Oh, okay.
Excuse me.
Unfortunately, Mr. Das. Unfortunately, okay.
But the name is fine.
Okay. Yeah, at least your name over there. Yeah.
Yeah, and picture I'll give you once I'll be in Jakarta.
Oh, okay. I will put it on the.
Yeah, right.
Okay, everyone, please open your camera so we can take picture together. Okay, nice to see all of you here. Miss Sinta, Bu Sinta, can you please help me to take the picture?
Sure, Pak Yuda. Okay, first slide. Cheese. Okay, smile. Okay, thank you. Next slide. Okay, cheese. Okay, smile. Thank you. Next slide. Okay. Oh, some of you still with the camera off. It's okay. Okay. Thank you. And the last slide. Thank you. Yes, we have done, Pak Yuda. Okay, back to
Okay.
you.
Thank you so much. I think we have reached at the end of the events. Thank you so much for all of the distinguished presenter for today, yeah, Mr. Timon Chukiaho and also Mr. Kundandas. We are really appreciate your presentation. I hope we can have the next collaboration activity to expose the development and the deployment of the operation in Indonesia, especially also at the TIP Community Lab at Telkom University. Again, thank you also for the attendance, all of the participants. Please be wait for our next webinar on the Open RAN and another advanced technology in the next future, bringing us the awareness and the knowledge on the top of technology to support the network deployment for the telecommunication industry. Okay, everyone, stay safe and healthy during this pandemic. Have a nice day. Thank you and goodbye.
Yep.
Thank you.
Bye.
Thank you. Bye.
See you guys.
Thank
Bye.
you all.
Thank you,
Yeah.
Mr.
Bye.
Thank
Timo
you.
and
You.
Mr. Kun.